EFR 516 students. Today we're working on example multiple regression, exercise 11. And multiple regressions similar to simple regression, but now we're adding another variable onto that. So instead of just like the line we see, we'll have a plane. And that's shown in chapter 11, page 432, where, for example, we have X1 age, weight, and then blood pressure. So you're defining a plane when you're doing multiple regression, at least with two variables. When you add variables, it's multiplanal and it gets hard to visualize. But the first one, he says, run a regression analysis, predict dependent variable 1 scores with independent variable 1, 1, and 1, 2 scores. Okay, given this equation, report the APA test for the slopes. Okay, then write up the equation for the line, include your summary tables. So then it's showing some steps here, analyze, regression, and where to move the variables. Okay, so we'll go to the data set in SPSS then, and we want to run the two independent variables here, IV11, IV12, and predict DV1. So we're going to go analyze, regression, linear, and then we're going to put the dependent variable under dependence, and then the independent variables under independence. So again, we're putting both 1, 1 and 1, 2 in there because now we're predicting with two variables. Then we'll say paste. That opens up our syntax window because this is the first time we're using the syntax window. We'll block that with our mouse, and then we'll hit the green arrow to run. Okay, and what we want to bring in is the ANOVA table. So to copy that, I'm going to go up to Edit, Copy Special, and I'm going to select Meta File because that'll allow me to scale it when I bring it in. And I'll say OK. So then I'll copy that, bring it into my document. Then I'll go get the coefficients tables. So here's my coefficient table. Copy that as well. Bring that over. I'll move the two tables down so I can include them. I can read from them. Okay, so I asked you for the APA for each of the predicted independent variables. So here we're looking at the ANOVA table, and it has our degrees of freedom. And then we're looking at the coefficient table right here, and each one is the test. So here's IV11 and IV12. So we want to write the test for those. Now we could write the overall model. The overall model is significant, but right now I'm just asking for these two right here. So it's a T with, we're getting the degrees of freedom from the ANOVA table, 96, equals, so we're on IV1. The T value is equal to 10.784, comma, and then here we see P is less than 0.05 because right there the sig is 0, 0, 0, right? So this was for IV1, 1. Okay, so now we'll go ahead and do it for IV2, IV1, 2. Okay, so and again, this should have been 0.05 here. So the degrees of freedom are the same, but now I'm right here under the T and IV12. So the T value is 5.0 0.895. And again, p-value is less than 0.05. I don't know why I have 0.05 trouble here. 0.05. Okay, so those are my APAs for each of the coefficients in the model. So they're both predicting the dependent variable. So I'm going to highlight these, put those in yellow for I can grade them. Okay, then it says write your model down here. So the equation, so here's the form of the equation. So, and we're going to look here. So here's our intercept. The constants are intercept. So that's minus 7.980. And the coefficient for IV11 is 0.628. And for IV2, or X2, is 0.299. So again, now this is writing it in the equation form, but our variables are named dV1, for example. So we're going to go ahead and just rewrite these in the actual variable names of 7.980. And we have 6 point, and then we have 0.299. So that's our actual equation with the variables that we have in this. And that's what you'd use in your analysis in your model. As we see our two slopes here, the 0.628, the 0.299, for 1 unit of change in IV1, that's how much y would change, the dependent variable. For 1 unit of change in IV12, that's how much the dependent variable I2 would change in that plane. So as you see on, again, page 432, those would be your coefficients. Okay, so that's what I want you to do for this problem. And now we'll go on to the next one. So we saw both those were statistically significant, right? And you'd be really happy with a model like that. Okay, so now we're going to run the next one. So it says DV2 and IV21 and 22. So a similar type of analysis, but down here it's saying, using the ANOVA table, confirm your R squared that's reported. So we're going to have to confirm the R squared for this problem. So we'll go to SPSS, come in, and we'll go Analyze, Regression, Linear. Okay, we're going to reset this. And we're going to take DV2 as a dependent variable, IV1 or IV21, and IV22. Okay, I'll go ahead and paste that. Then notice the syntax window doesn't open this time. I'm going to go down to my SPSS symbol and click on that, and that'll open the syntax, or shows me the window. I'll go ahead and block this last one, and I'll run this. Okay, so now we're being asked about R squared, so we're going to bring that table over as well. So we're going to bring over our R squared table. Our ANOVA table, and our coefficients tables. So there's my R squared. Here's my ANOVA. And now I need my coefficient table. And when you're running analysis, it's really good to keep track of like these tables. You'd bring these over in practice, and then you'd write your reports off that. So the tables are very important along with your syntax. So I'm just going to bump all these down so I can see them all on one page. Okay, so there's my analysis. So the first thing we're asked for is the APA, the test for the coefficients, and those are going to be similar tests up here. Okay. So then for IV underscore 2 underscore 1, it's a t-test with degrees of freedom of, need to see the ANOVA table, 96. Its value equals, right here on that line for IV21, the value that where T, the column for T and the row for IV21, there's our T value. It's 0.697. So it's 0.697, comma, P is what? Greater than 0.05. Okay, because 0.487 is greater than 0.45. So that is not statistically significant. Okay, we'll go ahead and write that for IV underscore 2. Again, it's a T with 96 degrees of freedom. Get that from the ANOVA table. Equals, its value is 0.014. Get it right over here. Again, that row and then that column, comma, P is greater than 0.05. Okay, so neither one of these are statistically significant. And if that we're hoping they were, demonstrating that there's an association between these and the dependent variable, we'd be disappointed. So we'll go ahead and write the model anyway. So coefficients then are 2.048. The next one is 0.007. Basically 0.001 we'll put up here. So basically there's no relationship between this for 1 unit of change in the independent variable, how much is change in the dependent variable, and so you get virtually no change here. So using the actual values here, we end up with 2.048, 0.007, and then 0.00, and I'm going to put 001. And that's common. That happens when something's less than 1,000th. Okay? And now the next part of this problem says, it's going to ask us, using the ANOVA table, confirm that the correct R squared is reported. So here our R squared is right here. I'm going to go ahead and move it down closer to this problem. Okay, so R squared is the percent of variation about the model, in Y, that the model explains in Y. It's percent of variation in Y that the model explains. So we see here it explains very little. It's less than 1%. Okay, but we're going to go ahead and confirm that. So we confirm that through the ANOVA table, the regression, how much is explained over the total. So here we see it's 1.093. 1.093, and we're going to divide that by 214,761. 214,761. Let me get my calculator out. So 1.093 divided by 214.761 and we end up with 0.00509. So rounding up to a thousandth anyway, we can confirm that the r-squared is correct in this problem. Okay, so that's it for that one. So now let's go on to the third one, the third final one in this exercise. So run a regression analysis, predict dv3 from these two variables. Now note that what we're testing is the slopes, right? Now when we write the equation, we're using small b, but here we're using beta because we're talking about the population. And the question is it equal to 0 or not equal to 0? If it's not equal to 0, it implies there's some linear relationship. There's some line in the data that explains some of the variation in the analysis. Okay, so we'll go ahead and go back to SPSS. I'm going to come up and go Analyze, Regression, Linear. I'll reset this. So we got dependent variable 3, independent variable 3, independent variable 3, 1, and 3, 2. Now we're asked to include some plots here. We're asked to include some plots. Okay, apparently we're not asked to do some plots. But in the actual assignment, you're going to be asked to look at some tables. No, here, I guess here it is. It says include the plots and the analysis, z predict to x, z resid to the y. Check your histogram box. So then it says including in your summary tables from SPSS, how do the residuals look? So we're gonna check the residuals because one of the assumptions of regression is that your residuals are normally distributed. So going back to SPSS, I'm going to go plots, and I'll put z predicted on the x-axis and z resid on the y. I'm going to click on histogram. I'm going to say continue, and then I'm going to paste. Okay, I need to go down to my SPSS symbol. I click on that, shows me the syntax. I select that, and I'll run this analysis. And notice that we're given some a plot this time, and the question is, are they normally distributed? Well, the real question is, are they distributed in the population? But in the sample, we never expect it to be perfectly normally distributed. But as you look at the curve imposed in it, it looks pretty good. I say these look pretty acceptable as residuals. So what you don't want is some far out outlier or some trend in the residuals. So we'll go ahead and we'll bring the ANOVA table over. And then we'll bring the coefficient table over. And then I want you to bring the graph over. You can bring the histogram as well if you'd like, but this is the one I'm interested in. Bring that over to for the assignment. Put it underneath everything here. And I don't need it that big. You can shrink it down. We're bringing it in as a meta file, so that's very shrinkable. And I'm going to go ahead and get the histogram as well, because in your assignment on your team, on your research team, you might want to look at that. You might want to show them that. That'll give them some confidence that there's evidence that you're meeting the assumptions of the regression analysis. And again, you can shrink that down. Okay. So here we are. I'm just bumping down again so we can see it all on one screen. So I need my APA for my coefficients. So the first one's testing independent variable, which is 3, 1, and it's a t with 96 degrees of freedom coming from the ANOVA table under residuals and degrees of freedom. Its value of the t, right? I'm on right on this row right here. So the value is 51.939, comma, then p is less than 0.05. Okay, so then we'll write the next one. So independent variable, 3, 2, and again, whatever that variable is, it's a t with 96. It's equal to 0.364, comma, p greater than 0.05. Now again, if a number can't be larger in APA than 1, it doesn't get a 0 in front of it. But if it can be larger, like the t's, it gets a 0 in front of it. So we see that IV31 is statistically significant, meaning implying an association, but IV32 does not show that. So we'll go ahead and write the equation. Now, the equation you might use in your analysis might be just IV31, right? You might not use the entire equation, but for us here, we're writing the entire equation. So it's minus 3.111, then 0.933, and 0.007. We're getting these from our coefficient. Now, we're not using the standardized. There may be a reason for that. If you have a reason, you could use the standardized residuals, but we're just using the actual raw residuals, the unstandardized, right here, and that's this column right here. So that's our equation. And again, we'll write the same equation in the variables that we're actually using. Then we have minus 3.111, 0.933, and 0.007. Okay, so we'll just highlight the answers in yellow so they can be seen. All right, and then that's besides the graphs. I guess I wanted one statement about what do we think of the assumptions of the test. So how do the residuals look? Include the plots. So what we're looking for is, again, no big outliers or no patterns. So I'm going to say the residuals look fine. And fine would imply that we have no trouble with them. Okay, and that completes this assignment. This is an example assignment. You don't have to hand this one in, but you do have to hand in the non-example assignment. Thank you so much.